MobileNet V1 and V2 gave you a way to implement a neural network that is more computationally efficient. But is there a way to tune MobileNet or some other architecture to your specific device? So maybe you're implementing a computer vision algorithm for different brands of mobile phones with different amounts of compute resources, or for different edge devices. And if you have a little bit more computation, maybe you can have a slightly bigger neural network and hopefully get a bit more accuracy. Or if you are more computationally constrained, maybe you want a slightly smaller neural network that runs a bit faster at the cost of a little bit of accuracy. So how can you automatically scale up or down neural networks for a particular device? EfficientNet gives you a way to do so. Let's say you have a baseline neural network architecture where the input image has a certain resolution R, and your neural network has a certain depth, and the layers has a certain width. The authors of the EfficientNet paper, Ming-Hsin Tan and my former PhD student Kwok Le, observed that the three things you could do to scale things up or down are: you could use a high resolution image, so a new image resolution R. And I don't know how to denote a high resolution in a video like this, so I'm using this blue glow here to denote maybe a high resolution image. Or you could make this network much deeper, so you could vary d, the depth of the neural network, or you can make the layers wider. So you can also vary the width of these layers. So the question is, given a particular computational budget, what's a good choice of R, D, and W? Or depending on the computational resources you have, you can also use compound scaling, where you might simultaneously scale up or simultaneously scale down the resolution of the image and the depth and the width of the neural network. Now, the tricky part is, if you want to scale up R, D, and W, what's the rate at which you should scale up each of these? Should you double the resolution and leave depth and width the same? Or maybe you should double the depth but leave the others the same, or increase resolution by 10%, increase depth by 50%, and width by 20%. What's the best trade-off between R, D, and W to scale up or down your neural network to get the best possible performance within your computational budget? So if you're ever looking to adapt a neural network architecture for a particular device, look at one of the open source implementations of EfficientNet, which will help you to choose a good trade-off between R, D, and W. So that's it. With MobileNet, you've learned how to build more computationally efficient layers, and with EfficientNet, you can also find a way to scale up or down these neural networks based on the resources of a device you may be working on. So with this, I hope you have the skills needed in order to build neural networks for mobile devices and for embedded devices and for other devices where the computation and the memory may be more limited. I hope this will open up a lot of possible applications that you may now be able to build.